We're the Robo Maniacs, and this is how we built our winning robot.
We noticed that most good teams build box-shaped robots so they can square up on walls and also make attachments that just slide over the top. And we use these double bent lift arms on the front corners, so if we hit a wall or something else, we can slide past it instead of getting stuck and having to take a touch penalty.
We used the biggest wheels we could find so our robot could go fast when we need to. And we put axles going all the way through the frame, the wheel, this central beam, and the motor so the axles won't bend when you have a heavy attachment. We even made bushings like this out of bricks to go on either side of the wheels and prevent them from tilting, because it messed up our steering when that happened the first year. You also probably want to invest the $90 or whatever for the EV3 rechargeable battery pack, because it gives a really uniform power output almost the whole time, way better than regular batteries.
We wanted our robot to be as skinny as possible so it can maneuver well and fit between things on the playing field. We think 16 studs is about the smallest you can go, and it lets you put the drive wheels far enough apart to steer accurately. You also want to keep most of your weight over the drive wheels for traction, which usually means putting them toward the back because you want your brick there. Our robot is 25 studs long, and we think you could make it 22 or 23. We just use little wheels on the front, without tires, so they can slide sideways easily when the robot turns. We tried these boat studs one year, but they have more friction and they can actually get worn down over all the robot work of a season.
We attached the L and M motors to each other and to the walls to make our robot as rigid as possible, and our walls go almost down to the mat. You can't drive over things this way, but you also won't run over a loose Lego and get it caught under your robot and get stuck. You can push things around the field easier. We also put a 16-line axle under the front so we can just slide our color sensors wherever we need them. And we put half bushings on either side so we can tell if they get moved out of place. And you can put big motors facing either up or down. There's a programming block that can invert the motors if you need to. So the positive speeds always go forward and negative speeds always go backward.
You definitely want to get an account on Brinklink.com, which is like an eBay just for Legos. You can search for individual pieces, build up a wanted list of everything you need, and the system will automatically fill shopping carts for you at the cheapest sellers. You can get lift arms, pins, axles, and everything else. These really useful frames are part number 64179. Our big knobbly tires are 11957. And the wheels they fit are 88517. And if any of your mission models get lost at a tournament, like our tube module did this year, you can just order those parts from the original instructions and build yourself a new one.
The other hard part is how to interface the motors to your attachments. We use these dog gears for a solid attachment, but the problem is that it's hard to align them exactly. Your attachment could be off by up to 30 degrees either way. That's fine for hammering the escape velocity mission, but it wasn't accurate enough to lift Gerhardt up into the airlock like we hoped. And what you don't want to do is to put a bevel gear on the motor and just try to put a big gear vertically next to it. We found out the hard way that the gears will strip with the attachment just bouncing up and down, especially if you need more than a tiny bit of torque. And you can't put these nice big gears flat next to each other because their centers aren't spaced by a whole number of studs, but a half number. But you could use these old style gears next to each other, and that should work.
For attachments, the main thing is to make them rigid and robust. We like these feeder beams that will center our robot on an attachment, like to insert the tube module or to do the resource extraction. You can make little axle arms that pivot up to go in, but then lock and drag things out. We also like to build wall followers so we can steer 1 or 2 degrees toward the wall and always line up exactly with something once we get to it. We use those whenever we can. You just have to make sure that the front and back wheels of your wall follower are far enough in front of and behind your drive wheels, or you could just end up turning to face the wall and getting stuck. Thanks for watching. If you thought our video was helpful, be sure to like and subscribe.